Solving equations with variables on both sides of the equation. At the end of this lesson, you should be able to answer the question that you see on your screen. Let's illustrate this process with an example. So, as you can see, there are two variables in this problem and they are on opposite sides of the equation. What we're going to do first is remove parentheses by using the distributive property. So I'm going to separate my two sides of my equation and distribute the 4 to get 4x plus 12, bring down the minus 2, and recopy the right side of the equation. Now I'm going to look for any like terms that occur on just one side of the equation. So on the left, I have 12 and negative 2. We'll combine those to get 4x plus 10 equals 2x plus 6. Now there are no more like terms on just one side of the equation, so my goal is to move all the variables to one side of the equation and my constants to the opposite side. So I'm going to choose to subtract 2x from both sides because I like to bring my variables over to the left. This will give me 2x plus 10 equals 6. Now this should look like just a two-step equation. I'm going to continue to take my constants to the opposite side. So I'm going to subtract 10 from both sides to get 2x equals negative 4. And finally, whatever operation I need to do to finish isolating the variable, in this case it would be divide both sides by 2 to get x equals negative 2. Let's do a second practice problem here. So again, I'm going to start by distributing to get rid of my parentheses. And on the right, you have to understand that there is a negative 1 in front of that set of parentheses. So you're going to distribute that to the two things inside to get negative 3x plus 2. Common mistake is that kids write minus 2. And I'm just going to recopy the left side. Although I could combine the like terms that I see there. But now I'm going to identify my like terms. I see a 3 and a negative 10 over here, which gives me, I like to put my variable first. I put 3x, this would be minus 7, because 3 minus 10 is negative 7, equals, and my like terms on the right are 8x and negative 3x. So 8x minus 3x would be 5x, and bring down the plus 2. So now I have no more variables on just one side of the equal sign. So I'm going to bring my variables. Now I could take them over to the right, but I always like to bring my variables over to the left, this side. So I'm going to subtract 5x from each side and subtract 5x from over here, which gives me negative 2x minus 7 equals positive 2. Getting closer, now I need to add 7 to combine my constants, which results in negative 2x equals 9. Finally, to separate the coefficient from the variable, I divide both sides by negative 2 to get a final answer of x equals negative 9 halves. Now, in Algebra 1, we often leave our answers in fraction form. We just want to reduce it if possible, but 9 over 2 does not reduce. We never change it. You can change it to decimals, but typically we leave it in fraction form because if it's repeating, you don't want to round because your answer will be slightly incorrect. Let's look at an application. The membership fee for joining a camping association is $45. A local campground charges members of the camping association $35 per night for a campsite and non-members $40 per night for a campsite. After how many nights of camping is the total cost for members, including the membership fee, the same as the total cost for non-members? So the first thing I'm looking for is, what's my unknown? So I reread that sentence with the question mark, and it says, after how many nights? So I'm going to create a variable and let n be my number of nights. And I'm going to use that then to represent the member versus a non-member. And the question is, when will the cost of a member, so a member cost, equal a non-member cost? All right, so let's write an algebraic expression that explains what a member pays. So just for being a member, you're going to pay $45 plus you have a cheaper cost per night, $35 per night. So if you were a big camper, you'd probably look at becoming a member. But if you only camp once in a while, it might be better to be a non-member because they don't pay that $45 fee. They just pay $40 per night, so that's 40 times the number of nights. And there is our equation. The algebra becomes simple. So we want to combine our like terms. This time I'm actually going to take my n's over to the right side because I only have one constant. So I choose to bring my variables to the right, which results in 45 equals 5n. One more step of dividing both sides by 5 results in n equals 9. So that means for 9 nights, the cost would be exactly the same. Now if you think about which would be cheaper if you stayed only 6 nights, well, I hope you recognize it would be cheaper to be a non-member in that case because you're not paying that additional $45. But if you would camp more than 9 nights, it's better to be a member. The last 2 questions on your note guide are special cases. So again, variables on both sides, so I begin by trying to combine my variables. I would, first of all, separate my 2 sides, and I see that I have 4x on both sides, so I'm going to subtract 4x and subtract 4x over here. Well, 4x minus 4x is 0, which leaves me with just negative 3/10 equals, and again, 4x minus 4x is 0 equals 9/10. So something weird has happened here. The variables have disappeared. So what you want to do is just double check and make sure you didn't make a calculation error. But we didn't. So you ask yourself, is this a true statement? Does negative 3/10 equal negative 9/10? And it certainly does not. They are not equal to one another. So what's happening here? The answer is not negative 3/10 or 9/10. The answer is that it doesn't exist. There is no such number that we could ever plug in for x to satisfy this equation. So when we're asking what could x equal, well, it couldn't be anything. There is no solution to this problem. Sometimes in algebra we use this notation, which is a circle with a slash through it. This means the empty set, because sometimes we list our answers in what's called set notation. So you will see this symbol from time to time. Right? The 5th problem is another special case that could occur. And in this scenario, we again start by distributing to get rid of our parentheses, which results in 12x minus 6, recopy the plus 15, equals 12x plus 9. Then you need to combine your like terms. I see a negative 6 and a plus 15 over here on the right. So I like to put my variable first, 12x, and this would be plus 9 equals 12x plus 9. Now hopefully at this point that you immediately spot that there's something special happening here. The left side is identical to the right side. When this occurs, this is called an identity. And the left is the same as the right. When this happens, this means that everything that possibly could be plugged in for x is a solution. Now if you don't recognize it yet, if you just continue solving this, subtract 12x from each side, you would get 9 equals 9. And again, the variables disappeared, so it's a special case. But this time, this is a true statement. 9 does equal 9. So the solution is x can be everything within the real number system. So we say that our solution set is the set of all real numbers. So, just to summarize special cases here, if your variables drop out and you get something like 0 equals 4, this is not true. 0 could never equal 4. Therefore, this is the empty set or no solution. However, if all your variables drop out and you get something like 7 equals 7, that is a true statement. 7 does equal 7, so the solution set here is all real numbers. You should now be able to solve equations with variables on both sides of the equal sign.